All right, so again, the conjugate root theorem says any solution that has an imaginary number I or a square root in it also has to have its conjugate as a solution as well. So what we're going to be given is we're going to be given a polynomial function, or it's going to tell us that a polynomial function has these given solutions, and it's going to ask us to find the other solutions. In these particular examples, it says find two other solutions. It won't be like that always. Sometimes there will only be one other solution. Sometimes there will be multiple other solutions. And I'll show you an example of what those would look like in your homework in just a couple of minutes. But it gives us two solutions of a polynomial, and it asks us to find the other two solutions. Again, this is using the conjugate root theorem. It has the imaginary number or a square root in it. Its conjugate is also going to be a solution. So if I take a look at number 1, my two solutions they are given me are negative 2i and a positive square root of 10. So based off of that conjugate root theorem, what would my other two solutions be? If I have a negative 2i, what's the conjugate of that? Positive 2i. And if I have a positive square root of 10, the conjugate of that is a negative square root of 10. So those would be my other two solutions. That's my answer. Does that make a little bit of sense? Sort of. Okay. Number 2 says my solutions are I, and then 7 plus 8i, and it wants to know what my other two solutions are going to be. If I is a solution, what is its conjugate? Negative I. And then if I have 7 plus 8i, what's the conjugate of that? Yeah. And those are my other two solutions. Not very difficult, right? Okay, go ahead, if you haven't already, do 3 and 4. Number 3 has solutions of 14 minus the square root of 2 and 6i. What would my other two solutions be? And then the other one? Negative 6i. Perfect. And then number 4 says my two solutions are 1 minus 2i and then 2 plus the square root of 3. What would my other two solutions be? And? Conjugate root theorem, it's going to give you, bless you, some solutions. The conjugates are also solutions is kind of what it asks you. Now, in your homework, I put, you don't have to write these down, but I just want you to know what it looks like. It's going to look like this in your homework for this section. It's going to tell you the degree of your polynomial. What does that have anything to do with? That tells us how many, well, if your degree is 3, that tells you you should have 3 solutions, like 3 numbers, right? Okay. And then it's going to give you a few answers, 1, 2, 3, whatever. Remember, the only ones that need conjugates are imaginaries and square roots. I already have 2 answers. That means I only really need how many more? 1. So which one of these needs a conjugate? I. So what would the other answer be? Negative I. So that's what you would put for your answer. Okay, but it looks like this in the book. It tells you the degree and gives you some answers. Here it says my degree is 6, which means I should have 6 answers. This says negative 2 happens how many times? Twice. Okay, so that's 2 answers. And then I've got these 2, which gives me a total of 4. Does this negative 2 need a conjugate? No, the only conjugates needed are for this one with the I. What would its conjugate be? Okay, and then this one with an I as well is going to be. So that's how your questions are going to look in your homework for that. It's just going to ask you for the answer, the other solutions. anything that has the I or a square root. Okay? If it doesn't have imaginary number or a square root in it, it doesn't need a conjugate. Everybody good so far? All right. Then we're going to start talking about solving some polynomials. We're going to stick to some basic ones today. We have solved quadratics before. Those are the trinomials that we factored and solved. So today we're going to look at solving a few different ways. We can factor sometimes, which we've done a lot of before. We can solve by using perfect squares, which I will show you, and we've technically done that before too. Or we may have to use the quadratic formula. That's something we haven't really done a lot of, or I don't think we've done any of that this year. But we have done it in the past, so we'll just have to refresh on that. The only polynomials we know how to solve right now at this point are quadratics. A quadratic is an x to the what power? X what is a quadratic? Squared. Yeah, x squared is a quadratic. So my directions are just going to say, solve each polynomial. We're going to find all of our zeros, all of our solutions. The next few days after today, we'll get into the harder ones that take a little bit more work. So my first polynomial, and I don't know why I have 5 listed twice there. I'll just renumber these. Sorry about that. Is P of x equals x squared minus 16. In order to solve a polynomial, what do we always have to have it equal to first? 0. So what I'm going to do first is I'm going to take away that P of x, and I'm going to put 0 in its place. Now, sometimes we can factor. So if you want to try to factor, you can. I'm going to actually show you this problem 2 different ways. Okay. First of all, x squared minus 16. That's 2 terms, an x squared and a constant, and those are both perfect what? Squares. So we can factor difference of squares as long as they are being subtracted. Are these 2 being subtracted? Yeah, so we can factor. So I'm going to do it that way first. I'm going to keep the 0. I want to set up my 2 parentheses. Excuse me. What is the square root of x squared? X. What is the square root of 16? 4. And then what do I do with my signs? Plus or minus. Before I continue, I want to see, are those completely factored? Is that as far as I can break them down? Yes. So then what we do is we just take each factor. We set it equal to 0 and we solve. We've done this all before. We factored and solved before. We're going to take and solve each one of these for x. And we're going to get 2 answers. Are we supposed to have 2 answers here? Yes. And what are my 2 answers? -4 and +4. That's fine. Is everybody okay with that method? Because I'm about to erase and show you a different method. So the direction said we could factor, or the second part said we could solve by perfect squares, and this is what I mean by that. Is everybody good if I erase this? Okay. I'm still going to start off exactly the same way by putting 0 in place of my P of x. Now, another way I can solve this, because I simply have x squared in a constant term, is I can get that x squared by itself. How would I get the x squared by itself here? Add 16 to both sides, yep. So that's going to be 16 equals x squared. And then I can continue to solve this by taking the, what of both sides? Square root. And when we solve an equation, anytime we take the square root of both sides, what symbol do we put out front? Plus or minus, right? And what is the square root of 16? 4, right? Isn't that the same thing I got by factoring and solving? Either way, it doesn't matter. To me, I think this way is easier. And I'll tell you why. Because sometimes we're going to look at problems and think we can factor when really you can't factor. And so the only way you could solve it is by doing it this method. This is the perfect squares. What we do is we get the x squared equal to a number. We take the square root and we solve. That kind of okay? All right, let's talk about 6. P of x equals x squared plus 9. The very first thing we want to do is get rid of that P of x and put 0 in its place. And here's the issue I have is some people are going to look at this and they're going to break it down into x plus 3 and x minus 3. Does this one factor? No, because it's x squared plus 9. So we can't factor this one, and I don't want you to make the mistake of trying to do that. That's why I said that second method I showed you is the easier of the two when you have an x squared and just a number. Okay? If you have an x in there as well, then it throws the whole thing off. So let's start working on this one. How do I get this x squared by itself? We're going to subtract our 9 over. Again, I cannot factor because it's x squared plus 9. And then I'm going to take the square root. Can we? We can't because what's there? It's a negative. But we did already talk about, it's been a while, but we talked about simplifying radicals with a negative, right? Okay. Do you recognize that I put the plus or minus in front first? Okay, that's going to represent my two answers. When we solve this, think way, way, way back. What we did was we took and we separated it into the square root of 1, or negative 1, I'm sorry, times the square root of 9. And what did we learn that the square root of negative 1 was equal to? I. What is the square root of 9? 3. So it's plus or minus I times 3, which the best way to write that is just plus or minus 3I. That will be my two solutions for x. A positive 3I and a negative 3I. Does that make a little bit of sense? Okay. All right, go ahead and try 7 then. Very similar. Remember, anytime you have a negative under the radical, that's where you're going to have your imaginary number. I'm going to replace P of x with 0 first. How do I get x squared by itself? So I get negative 1 equals x squared. So to solve for x, I'm going to take the square root. What symbol do I put out front? Plus or minus? And what is the square root of just negative 1? Just I. So my two answers are going to be positive and negative I. Today, not terribly. Tomorrow is when it gets confusing. Everybody ready? Okay. All right, let me renumber these two. That's 8. That's 9. Okay. All right, take a minute and write number 8 down. We'll talk about it and work through it together. Then I'll let you try 9. So before we start, just based off of my polynomial, how many answers should this thing have? 4. You are, in here, we have not talked about how to solve any kind of polynomial that has a degree of 3 or higher, right? All we've done is quadratics. So with these, we have to be careful. And I've seen some of you already working on it. And some people moved the 81 over and then tried to take the 4th root to solve for x, right? But that doesn't give me 4 answers, does it? No, okay. So anytime you have an x to the 4th, you are going to have to, at this point until we get to tomorrow, you're going to have to factor it first. There's no way to solve it if it doesn't factor. Does everybody understand? Okay, because of that x to the 4th, we have to be able to get all 4 solutions. If I add 81 over and try to take the 4th root, that does not give me 4 solutions. What I do want to do is look at this in terms of the first couple of the first question that we did. There are 2 terms. They are being subtracted. Are they both perfect squares? X to the 4th and 81, are they both perfect squares? Yes. So we are going to have to factor this first, setting up our 2 parentheses. What is the square root of x to the 4th? X squared. Okay, so that's going to break down into x squared and x squared. And then the square root of 81 is 9. And then what do we do with our signs again? 1 plus, 1 minus. Do those 2 factors look like things that we've just solved now? So from this point, we can take each one. Once we break it up into 2 perfect square factors, we can take each one of these and set them equal to 0 and continue to solve. Just like we did with questions 6 and 7. Okay, so finish it. We should have a total of how many answers? 4. So you want to make sure when you finish that you have a total of 4 answers for this. Again, anytime you have an x to the 4th at this moment, we have to be able to factor to solve because that's the only way we know how right now. And then you're going to do it just basically like we did right here. Well, first we got to take the square root first, right? And then because of that, make sure there's no square. So it's basically just like this at that point, right? Okay, same thing. But it can go. With this first one, x squared plus 9 equals 0, I have to do what with that 9? Subtract it. So I get x squared equals a negative 9. Okay, anytime you have a negative, we're going to have what in our answer? And we just did this. What is the square root of negative 9 simplify to be? 3i. So I got plus or minus 3i. That's 2 answers, correct?
Yes.
Okay. Then we're going to do the same thing to the other side, but this time what do I do to the 9? I add it over. So I get x squared equals 9. Still taking the square root, still putting my plus or minus in front, but this time it's just the square root of positive 9, which is just 3. Is that a total of 4 answers?
Yes.
Yes. So here's how you can write it. You can write it as plus or minus 3i, comma, plus or minus 3. Or if you wanted to, you could write positive 3i, negative 3i, positive 3, negative 3. Okay? Most people are just going to choose to put the plus or minus because it's shorter and faster. Does that make a little bit of sense? All right, try 9.
Well, this morning was saying 7 more Mondays this morning, not including today. They don't come to school next Monday, so I'm gonna say 80.
Wasn't somebody saying that we were having like full weeks? There's one day. There's been some first week about it.
Well, next week we start school Monday, but that's the last holiday that we have.
I don't know, somewhere in my first.
You just skip one day a week and it'll be a reality. Because I know you're about to do that.
I maybe they were thinking like, because the tournament
On Friday, you're gonna be like to your girlfriend, you're gonna be like, let's go to the beach every Friday for the rest of the year. I was like, that's not the hours, but he's gonna be like, I don't like sand.
I don't like it.
I don't like sand either. It gets on my toes. Specifically my toes,
You have one of those.
I don't.
Like, people have those like menstruation, those are.
No, I love when her toes like spread out.
When he like drops the toe with her toes and then Frank like cuts all her toes off. That's how I no, I'm kidding. That's not what he does. It's not what he does. He does the thing with the knife and he goes in the stove and her arm starts sizzling.
that may be what it is.
And she shows up to the hospital and then he's
All right, I have an x to the 4th, so I have to factor first, yes? How does this factor into?
Squared minus 1 plus 1.
Mm-hmm. All right, one of each. Then we take each one of them, we set them equal to 0, and we solve. This time I have to subtract 1 on this first one. So when I take the square root, I'm taking it of negative 1. So it's going to be x equals plus or minus, what is the square root of negative 1? I, okay. Then over here we add 1. We take the square root, plus or minus, what is the square root of positive 1? Positive 1. So my 4 answers, which I'm supposed to have, positive or negative I, positive or negative 1. Again, you could write that as I, comma, negative I, comma, 1, comma, negative 1 if you wanted to as well. So we factored, we took perfect squares. What was that third part that we said we might have to solve using? Quadratic formula. This is 10. No. They don't factor, yeah. All right, so these will be the last 2. We're going to work through them. I'll work through the first one together with you. I'm going to let you try the last one. So the first thing is we have to remember what the quadratic formula is. I'm not going to see it for you because I cannot sing. But it is negative b. Anybody remember?
plus or minus the square root
Uh-huh.
of 4 b squared minus 4ac all over 2a.
There you go. And I will give that to you. I won't make you memorize it.
It's an actual song. It's very bad. Don't ask.
So how do I know when I have to use the quadratic formula? When I can't factor it, right? So let's take a look at this first one. P of x equals x squared minus 4x plus 5. That is a trinomial, and normally we could factor and solve, which we've done before. I'm going to change that p of x into 0 again, but here's the question. Are there numbers that multiply to give me 5 and add to give me 4? 5 plus 1 is 6, not 4, right? If you put a negative, then you're technically subtracting, not adding. There are no factors that multiply to give me 5 and add to give me 4, which means I am going to have to use the quadratic formula to solve this. Okay. Where do we get a, b, and c from? Do you remember? Yeah, your polynomial is ax squared plus bx plus c. So what I like to do first, before I plug it into the quadratic formula, is I like to write down what my a is, what b is, what c is. So based on this polynomial, what is a and what number's in front of x squared? Okay. And b is the number in front of x, which is -4. And then c is the number by itself with no variable, which in this case is 5. Okay. Once I have a, b, and c identified, it is a matter of plugging them into my formula and simplifying it as much as possible. Sometimes we'll have radicals left, sometimes we won't, sometimes they'll simplify with imaginaries, sometimes they won't. So let's start. It's going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Start simplifying under your radical first. However, what is the opposite of -4? +4. Okay, plus or minus. What is -4 squared? Okay. And then -4 times 1 times 5 is, at the bottom, 2 times 1 is just 2. So far, so good? Okay, we'll keep going under the radical. What is 16 minus 20? Then we have to ask ourselves, can we simplify that radical? Well, first of all, there's a negative under it, so I can pull out the I, and then check the number. Is 4 a perfect square, or can it be simplified with a perfect square? It is a perfect square, right? So we're going to go 4 plus or minus. This square root of -4, the whole thing, simplifies to be 2i.
Can you simplify it over 2? Okay.
In order to simplify, the number in front of the plus or minus, the number behind the plus or minus, and the denominator, all three places have to be able to divide by the same thing. And in this case, they do, right? They can all divide by 2. So 4 divided by 2 is 2. 2i divided by 2 is just I. And 2 divided by 2 is 1. So you can leave your answer like that. Or would it also be okay if I just left it like that?
Yeah.
We had an x squared, which means we have 2 answers. What I need you to understand, that is 2 answers. 2 plus I and 2 minus I. All right, I want you to try 11 because this one's going to simplify to be a little different. This is the last one we do. Because when partner numbers that multiply to give me 5 and subtract to give me 6. 2 plus or minus 1. Okay, good job. Somehow. I think I'll tell you, Mom. Did you write one? Whoa. My mom doesn't care about you like that. I'm calling the police. You're going to jail. This radical is going to simplify a little differently. Just remember, we've got to simplify. It's not actually positive again.
So 49 and whatever.
What?
6 plus 20 is 50.
No, she has 50 square.
36 plus 20 is 56.
Yeah.
Okay. Brain, no calculator.
That should be.
I should be like a human calculator, just like what's 2 plus 2? I got this guy. 2 plus 2 is 3.5.
Yeah.
Yeah.
Yes.
Those kindergartners, bro, they're so stupid.
Where did you get 30?
6 squared is 36 minus negative 4 times 1 times negative 5 is 40.
Yeah, you don't.
Okay, so.
Oh, it's 483, okay.
I see some people up to a certain point having the right answer.
What do I do? How do I simplify this? What do you mean?
Four, 9, 16, 25, one of those.
What do you mean it divides into it?
So like, you're good, if we have like, say, the square root of, we don't split that up.
Okay,
Right.
I forgot about that.
Yeah. What is A in this problem? 1. What is B? And then C is? Okay. A is 1, B is 6, C is negative 5. So we're going to start plugging it in. The opposite of B. Yeah, that's a B. That's just me writing sloppy. All right, so the opposite of 6 is negative 6. 6 squared is 36. You have to be careful on this last part. Negative 4 times 1 times negative 5 turns into a positive 20. So I get negative 6 plus or minus the square root of 56. And I saw that on most people's paper. So far, so good. Now, there is no negative under a radical, so I don't need the imaginary, but I do need to see if 56 can simplify, like breaking it down into some perfect square times some non-perfect square. What perfect square divides into 56? 4 times 14. So I'm going to split that into 4 times 14.
Oh, 4.
What is the square root of 4? 2. So now I have negative 6 plus or minus 2 square roots of 14 over 2. And again, the number before the plus or minus, the number after, not the one under the radical. And then the number at the bottom. Can they all three divide by the same thing? Yes, they can all divide by 2. So that's going to give me negative 3 plus or minus. You can put a 1 in front of that if you want to, but you don't have to. Or we could just write it as negative 3 plus or minus square root of 14. Either one of these will be fine. Anybody have any questions?